Hello, so in this video we will talk about a concept called derangements. So the definition of derangement is a permutation of objects such that no object is at its previous position. So what do we mean by this? That if we have three objects, 1, 2 and 3, so we change the position of 1, 2 and 3 in such a way that none of them is at their initial position. Now 1 is replaced by 3, 2 is replaced by 1 and 3 is replaced by 2. Another maybe is 2, 3, 1. So 312 and 231 is a derangement of n objects. Okay, now it is of interest to find how many number of derangements are there for any given objects. So for example, if we have n objects, how many derangements are there for n objects? And this is also this is also an application of our inclusion exclusion principle, and we'll see why. So our job is to find the number of derangements of n objects. Okay, so in order to do that, we start like this. We say let ai be the set of all permutations such that ith position is preserved. Okay, so ai is the set of all permutations such that the ith position is preserved. So what do we mean by this? So for example, we are talking about n is equal to 4 here. 1 2 3 4. So then a2 will have 2 here, and then we can play around with these three spaces here. So it can be 1 4 3, it can be 1 2 3, it cannot be 1 2 3 4 because 1 2 3 4 is already taken care of. 3 2 4 1 and so on. The point is that this position is not changed. This so this permutation and this permutation and all those permutations in which 2 is not changing its position form the set A2. Okay, so then the number of derangements is, so what, before we go talk to the number of derangements, let's say what does this mean? We say A1 union A2 union A3 up to union AN. What does this mean in words? This means that this set will have all the elements will have at least one position preserved, and the cardinality of this set is just the cardinality of the set in which all the elements will have at least one position preserved. Okay, so now the derangements is, we can say derangement is total number of permutations minus this set A1 union A2 up to union AN. Okay, so what is the total number of permutations for n objects, which is equal to n factorial? So we say n factorial minus A1 union A2 union AN. Now this guy, now we use the formula from the inclusion and exclusion principle. So this is equal to n1 minus. So now this is a big bracket here. So we'll say I AI minus IJ AI intersection AJ plus AI intersection AJ intersection AK minus plus, and what is the last term? Last term is minus 1 to the n A1 intersection A2 intersection up to an. Okay. Okay. Now the question is, what is this guy? This guy is, so let's zoom into this part. We have a summation and we have the cardinality of a single set. So the cardinality of this set is n minus 1 factorial. Why? Because remember, go to this one. We have two fixed and we can play with um, three spaces. So if we have three spaces, how many permutations can we get? We can get 3 factorial. So if we have one position fixed, we can play with rest of the n minus 1 factorial, n minus 1 positions, so that the number of permutations will be n minus 1. So this means my earlier argument that 1, 2, 3, 4 is not allowed is probably not true. So 1, 2, 3, 4 is included in that set. Okay. So then this is just n minus 1 factorial. Now how many do we sum? How many i's are there? Now we are choosing one element. So now how many elements can we choose? We can choose one. We have to choose one element from n elements. So then this is n choose 1. Now let's go this one. Now here we have two positions preserved, position I and position j, and we can play with n minus 2 factorial, n minus 2 positions, so that's why we have n minus 2 factorial permutations. And then due to this summation, we can choose those two positions in n to choose 2 ways. Okay. So similarly, if we do all this, then we get our number of derangements. This is equal to n factorial minus, first one is n times n minus 1 factorial, second one is plus, we say n factorial over, this is nc2, so n minus 2 factorial, n minus 2 factorial. Then we say this is a minus here. Okay, so then we say plus minus, and what is our last term? Our last term is minus 1 to the power of n plus 2. This is n choose n, and then we have n minus n factorial. Okay, this is actually just writing it so that it's just 1, because the last term is what? Our last term is just a1 intersection a2 intersection up to an. Okay, this term is 1 because there's only one set in which all the positions are preserved, which is the set itself, the starting set. So this is just 1, but we have to write it in a way so that we can make an association here. Okay, so now this guy cancels out with this guy, and this guy I can write it as n factorial over 0 factorial n factorial times 0 factorial. So this goes with this. Okay, now what I will do is I will take n factorial common, so I'll say n factorial 1 minus, now this guy is what? 1 over 1 factorial. This guy is what? 1 over 2 factorial. Then we have 1 over 3 factorial, and then plus minus, and then we can get minus 1 to the n plus 1, 1 over n factorial. How does this n plus 2 change to n plus 1? Because I'm taking this minus sign, I'm absorbing this minus sign inside the brackets, I'm taking this n factorial common here. So now note that this thing is 0, so you can start directly with this one. But in normal texts, in usual texts, this is actually included here just to show uh, some pattern here. Okay, so another thing, so this is actually known as dn. Okay, so in other words, if we say dn to the n, this is equal to 1 minus 1 over 1 factorial plus 1 over 2 factorial minus 1 over 3 factorial and plus minus 1 to the n plus 1 1 over n factorial. Okay, so this is d n over n factorial. So now this is what? E to the minus 1 as n grows very large, right? And you can see that actually it approaches e to the minus 1 extremely quickly. It approaches about after 4 or 5 terms, it approaches e to the minus 1. So this is an interesting result, that the number of derangements divided by the total number of permutations. This approaches e to the minus 1 as n approaches infinity, as n grows. Okay. Okay, so this is a brief introduction about the derangements and a small application of the inclusion exclusion principle. Hope it was easy to understand, and hope you liked the video. Thanks for watching.